Hi everyone, today we'll solve this question search in rotated sorted array. We have given a sorted array. As you see in this example, this is rotated four times. This array is 0, 1, 2, 4, 5, 6, 7, and we have given a target which we have to find in this array, right? And if target is found, then we have to return the position of that target. Okay, so one of the simplest ways you can scan through this array and compare each and every element with the target. If there is a match, return that position. But the complexity will be big O of n since you will be touching each and every element of the array, right? So one catch here is this array is sorted, right? So whenever we have given sorted array, we have to take like advantage of that and we can apply binary search, right? Okay, but the problem here is you cannot apply binary search straight away, right? Because this array is rotated, right? So one way is you figure out the position where array is rotated. Let's say in this case, array is rotated till after third position, right? And take this as a two separate arrays. Consider this as a two different arrays, left array and right array, right? And sort these, apply binary search on these two independently, right? 0, 2, right? So this is our array 1 and this is our array 2, right? And first what we have to do is we have to find the position of where array is rotated, right? Find position, in this case 3, right? And which means that, so our we will have to apply binary search on 0 and 3, whatever position we'll find, right? And the second binary search will have to apply on position plus 1 and end, right? So this will also take O of log n, right? And this will also take big O of log n, right? And this position you can again slightly modify the traditional binary search and figure out this position. So in traditional binary search, what we do is we compare if array of mid is equals to target, right? So here, instead of comparing this, we can check one of the ways we can check if our next element is smaller or previous element is greater, right? Then in that case, we can consider that as a rotation point, right? So for example, in this case, 7 is greater than 0, right? Let's say our 7 is our mid and we can check if it is greater than array of mid plus 1. And similarly, we can check for mid minus 1 and then consider that as a pivot or position, right? And call this method. So again, we can slightly modify this binary search and figure out the position of pivot element, right? And this again will be big of log n, right? And the total complexity will be O of log n plus O of log n equals to O of log n, right? But now the problem is like the complexity wise it's fine, but again we can do little better, right? So what we are doing is we are figuring out position, then applying on the binary search on these two arrays separately, right? So let's think about how we can do better, right? So what we can do is we have to figure out which half of the array is sorted. Let's say our mid is this, right? So if this array is sorted, then definitely our start will be less than our mid, right? Which means this array is sorted, right? If it is start is not less than, let's say here we have a 4, 5, 6, and 3, and what do you call 12 and 13, right? So here in this case, 4 is greater than 3, which means our this half is not, this half of the array is not sorted, and the right array is for sure sorted, right? Because one of the half has to be sorted, right? Because it's a sorted array. If it is not sorted, this one, then definitely our right half is sorted, right? So you just have to take advantage of that. We have to figure out which half of the array is sorted, and we will apply binary search on that. So maybe like let's see how we can write the code, then you will like understand it better, right? So this complexity wise, this solution will also be big of log n, right? But again you are avoiding that extra effort. It's slightly better to find the pivot and apply binary search on two halves, right? It's slightly better, I think so. So So here, like what I'm doing is I'm calling the same search method array starting from 0, and this is my end nums length -1, and this is my target, right? So I'll write a recursive method to search for to s- like to search the element, right? And in binary search, what we usually do is if start is less than end, right? But here it is my base condition, right? If start is greater than end, that means element doesn't exist in the array, and I'll return -1, right? Else, what I'll do is I'll find the mid, right? Mid will be start plus end minus start by 2, right? Now we have middle element, right? What we have to do is we have to figure out which half of the array is sorted, right? We'll check if start is less than array of mid, right? If array of start less than array of mid, right? That means, sorry, less than equals to array of mid. That means my this half is sorted, right? Now next step is I'll have to figure out where exactly our element, my element exists. Let's say our target is 5, right? This condition is satisfied, 4 is less than 7. Now, but I have to find the element 5. So what I have to check is if it's the element is really in this range, right? If target is greater than, let me, let's say we have to find the 5, right? So we'll check if uh, we will check if target is greater than our low and it's less than our end. Basically, we have to figure out if it is in this range, right? So if target is less than array of target is greater than equal to start, right? And target is less than equals to array of end. So which means it lies in this range, and it's just that we have to apply binary search and figure out where exactly is that element, right? So we will just do start, and end will be changed to mid -1, and target will be passed as it is, right? So here we have to add one more base condition. If array of mid equals to target, that means we have found our element, right? So let's see the element is not in this range, right? Then we can search in right half, right? Search and mid +1 and high target, right? We'll search in this half mid +1 and high. Okay, so let's see this half is this left half of the array is not sorted, right? This condition is not satisfied. Then we will check if our element, or let's say target, is lies in the right half. So you don't really have to check again if your mid +1 is less than your end, right? Because this is a sorted array, so one half of the array has to be sorted. Okay, so you can simply start writing this kind of condition here. If your target is greater than your mid, right? Sorry, if your target is greater than your mid, and if your target is your less than array of end, right? Then we can do this search array mid +1 and target. If it's not in this half, right, then we will search in the first half. So we are just applying the traditional binary search, like the method which we discussed before. Here it's pretty much same. It's just that we are avoiding the effort to find the pivot element, right? But once we have one of the half of the arrays, like once we figured out which half of the array is sorted, we are just applying the normal binary search start to mid minus one, and if it is not greater, then we are just checking mid plus one high. Okay. So here, if the element doesn't lie in this range, right? What we will do is array, we will search in the first half. Okay, it sounds good. Array cannot find the symbol. It should be end. Let's run one more test case. 4, 5, 6, 7. Okay, let's try to run the try to search something which doesn't exist in the array, like 3 should return minus 1 in that case, basically this condition. Okay, now try to submit the solution. Okay, one of the test case is failing. Let's see where we are doing the mistake. This is fine, this array is sorted. Target is less than our mid, right? Because here we are talking about start and mid. Here mid and end, right? Now to run this test case, 1 3. It worked. Submit the solution again. It's worked. Yeah, thanks for watching this video. If you like, please give me thumbs up, and if you want to see more such videos, please subscribe to my channel. Thank you.